Hello, today we will look into black holes and how to develop an algorithm in order to conduct a brightness test on how bright the black hole is in radio sources. So where do black holes come from? The answer is simple. Stars. When supermassive stars collapse on themselves, the gravity is so immense that it will create a point in time that is infinitely dense and infinitely small. This is called our singularity. The singularity is so gravitationally infinite that no light can escape. So when we look at a black hole, we only see the event horizon where there's no light. So that's why a black hole is black. So since we can't see black holes, how can we detect them? So we have to think about the question, what do black holes release? Black holes are known for their radio sources, radio emissions, X-rays, and gamma rays. You can't see it with a visual telescope. Like if you put an eye to an eyepiece, you can't see a black hole. But if you detected them in radio sources, you would be able to see them in numbers. Black holes are everywhere, so we would be detecting multiple radio sources from multiple sources. So in order to detect a black hole with accurate measurement, you have to know about the sky near that black hole and the sky at the black hole. So we have to study the sky. So in this class, I said I would be developing our algorithm. I have a data sheet ready to go, and in that data sheet we have a few numbers, and the numbers include the black hole and the sources next to it and the sources next to it in corresponding order. And so we will be developing an algorithm to detect how bright the black hole is compared to corresponding sources. So I'll go to Atom, and for this algorithm I'll be using Python, but you can use any language you're comfortable with. So the first thing we're going to do is just comment. We're going to say ask what the 6 numbers are for the background interference. I didn't spell that right. Okay, so this is basically getting the background interference and setting it as a variable. And set as a variable. And then we will take this variable and we will variable divide by 6 to get the average, and this is equal to our new variable. And then we will take ask what the 6 numbers are for the second background interference and set as different variable. And then different variable divided by 6 is equal to new variable. Okay, so we're asking the background interference. We're dividing it by 6 to get the average. We're asking it again. We're dividing it by 6. Ask peak. So in radio astronomy, what we mean by peak is when we pass over the object and we collect the highest number. So our peak in our case is highest number black hole, okay? So that's our peak. And then we want to set this as a new variable. Like completely new, okay? Don't confuse this with this. Once we ask our peak, we will want to do new different variable plus, let's see, new variable. We want to divide this by 2. Okay, so this is our new different variable. And so we will set this as, I don't know, maybe total av. And then we will take peak, so new variable minus total val is equal to delta temp. And after all this is done, after all the computing is done, we will then say print delta temp. So it returns this value. And then that's it. That's the end of the loop. There's no if statements, it's just going through a bunch of variables, listing input. This will be really easy to do, so if you follow along, then I'm sure that you will get to the bottom of this. So delta temp is really good in astronomy because you'll be able to calculate the source, and you will be able to figure out how bright the black hole is relative to the sources next to it. In this case, we're talking in radio waves, so all this is radio waves only. So we're only talking so there's the electromagnetic spectrum, right? It looks like a rainbow, and in that electromagnetic spectrum we have visual light, radio waves, gamma rays, X-rays, what else? Thinking. Infrared. That's all I can think of right now, but basically all of this is easy to detect. We have an X-ray telescope that's in space. It's known as Chandra. We have a gamma ray telescope. We have our radio waves. We're getting our sources from DSS 28. You can search it up later. But DSS 28 is a telescope, and it's a radio telescope, and it's about 120 feet long, so it will give us very accurate sources. And we will be using this for this entire channel. And if you can, I want you to think about this algorithm and maybe tell me how to improve it. Because you can always improve stuff, and the better our algorithm, the better it will be, the more accurate values we'll get. So, please take a look at this algorithm and think about it, and change it. I want you to change it if you can. In the next video, we will be turning this algorithm into Python code.